Okay, so let's take a look at Assignment 6B, which is going to be the assignment that pertains to the tolerancing portion of this module. So you're going to notice that there's a PDF here, and you are going to download this, print this, and then you're going to be handing it in for this assignment. So what I do have is underneath my camera, I have this assignment. It's a couple pages long, and then you'll be filling in the information that we see in the pages to come. So I just want to do an overview of what the expectation is here. So we're going to review the information on the first 2 pages, and then we're going to, it says an allowance quiz. It's really not a quiz. It's just that from the resource that I got it from, it called it a quiz. So it's really just a fill in the blank type of a thing. And then there are 2 supplemental drawings, and then you're just going to scan and upload this to the Module 6 assignment or Module 6B assignment, okay? So let's first look at these first couple pages here. And this just gives us a little bit more detail and actually a little bit more vocabulary related to the things that we've been talking about this evening. So first of all, MMC and LMC. MMC means maximum material condition, and LMC means least material condition. And when I talk about LMC and MMC, I like to say that when I have the maximum material condition, it's when I have a condition where the maximum material condition or the maximum amount of material is left after I create that feature. Now, it depends. If I am an external feature, that means that the largest size within that tolerance zone is going to be the MMC size, okay? If I'm an internal feature, it's going to be just the opposite. It's going to be the smallest size. Now, what is an external feature? What is an internal feature? Okay. If you're filling in the stuff right now, I would love for you to stop because I'm talking about things that we haven't talked about that you need to learn, okay, before we talk, because you're going to be asked about MMC and LMC. So if I can have everybody's attention, I would love that. Thank you. So external feature. An external feature is going to be something that I touch the outsides of it in order to determine what its size is. So things like pins are going to be external features. I have to collapse down with the calipers or micrometers on the outside of it in order to find out what is its size. Okay. If I have the length here, okay, of this pin, that's another external feature. I don't have that dimension here, but I would have to collapse down with the micrometers or calipers on the outside of it in order to find out what that size is and compare it to what's on the drawing, okay? I could do that for rectangular features as well. If I look at my table here, the length of my table, the width of my table, the thickness of my table, touching the outsides of it, external feature. So when I'm an external feature, my MMC size is the largest size. So down here, you're going to notice that they identify on this pin, the 25.6 external feature is the MMC size, okay? Now, the LMC for an external feature, okay, and it says external down here, for an external feature is going to be its smallest size. So I like to say that external features go along with the verbiage of maximum and least. Maximum material condition for externals are always going to be the largest. Least material conditions are going to be the smallest. Okay. Now, internal features. Internal features are the exact opposite. And an internal feature, I really want everybody's attention, please. Please. All the stuff is here. There's no reason to take notes. And if you're looking ahead to try to get the assignment done and something doesn't go right or you have questions later on, I'm going to say to refer back to the video. Okay. Because if you don't want to listen now, then it's just going to take you longer later. Okay. I know the urge to try to just get done with the homework quickly, but please, I'm trying to give you information because this is going to be relevant to what we're going to be looking at in a couple pages. All right. Internal feature up here. It says when I have an internal feature, my MMC size is going to be its smallest size. When I have an internal feature, I'm taking material away to create it. So very popular ones are going to be holes. Holes is an internal feature. And then I think to myself, I have to go in and expand out with, for instance, a calipers to determine what that size is. I'm not collapsing down on the feature. I'm going in, I have to expand to it, okay? Another internal feature would be like a keyway. Okay, I have to, it's a non-cylindrical feature of size that I take material away to create. A cutout, a slot is going to be an internal feature, okay? So MMC is going to be the smallest size. So when we look here on this hole, this internal feature, 23.8 is identified as its MMC size, okay? And the LMC is just the opposite. It's going to be the largest size. Now, as I said earlier, when we look at maximum and least material condition, for maximum material condition, I like to say that the maximum amount of material was left behind after I made that part. So if this is the smallest size, the most amount of material is left behind in the part itself on an internal feature. Does that make sense? If I'm an external feature and I make it to its maximum material condition size, that one's, like I said, it's kind of easy. It's the largest size, right? Maximum, largest on external, opposites on internals. When I have the least material condition, I make it to its largest size. So now I made it larger. I took material away, right? So now that's the least amount of material that's left behind, okay? Now, why is this important? Well, it's how we refer to the different limits of any size, okay? Maximum material condition, least material condition. So knowing if it's an internal or external, we gotta get that, okay? And then we're going to be using this again in GD&T, and we're going to be using it again later on when we do engineering design projects. So this is a good start to that. Now, we already talked about allowance. So they have a little paragraph up here. And essentially an allowance, whether it's positive or negative, positive is going to be a clearance fit situation. And a negative allowance is when we're going to have a interference fit situation. Now, where the MMC becomes important, whenever we're calculating allowances, here is our standard equation. We take the MMC size of the hole minus the MMC size of the shaft, or the, and you don't have to say hole and shaft, it just means internal and external feature, because it could be non-cylindrical features, okay? And we subtract that off and we get our allowance, okay? We get our allowance. Now, down here, without really looking at the numbers yet, when I have a positive allowance, this is a clearance, okay? When I have a negative allowance, this is an interference. Interference. Okay? That means that in this case, 5/1000ths, both pieces are trying to share that same space. Okay? Over here, an allowance, that's the back and forth, that's the slop that we have in there. Okay? All right, that's the gap. So as we look up here, let's look at the numbers that we have, okay? So on the shaft side, on the left-hand side, so we're putting the left-hand shaft into the hole in the middle. We're putting the right-hand shaft into the hole in the middle. So the hole remains the same in both cases, okay? The shafts on either side are going to be different. So we have shaft A on the left, shaft B on the right. So if we look at our shaft A, what I want you to do is it has 0.997 plus or minus 1/1000. Write out the limits. What's the high limit and the low limit for this size with this tolerance on it? Okay. And you can write it right alongside, like over to the left. Okay. We want to show the actual limits here. Okay. So tell me, what is the high limit of this size? If you're virtual, you can put it into the chat box. That's totally fine. It's going to be 0.9. What is it? So 0.998, Roman says. Anybody else get that same number? Okay, awesome. If you need a calculator, go ahead and use it. I am very calculator dependent. What is if I take minus 1/1000, what's my number? .996, right? So we're taking the 0.997, we're adding 1,000, subtracting 1,000. These are our limits. Okay, so our high limit is 0.998, our low limit is 0.996. Now, MMC, which number is my MMC size? If you have to look back, go ahead. Okay, if you have to look back on my shaft, which is my MMC size? Roman is saying, is it 998? I don't know. 998, maximum material condition for a shaft. Is a shaft an external or an internal feature? External, yes. So when I'm an external feature, right? The MMC size for an external feature is the largest size limit. Yes. So yes, Roman, you are correct. That top number is the MMC size. So that means the bottom number is the LMC size. Let's look at the hole. The hole is telling us we have a diameter of 1 inch plus or minus 1 thousandths. Put the limits of size for that hole. Okay, what's its high size? What's its low? I'm gonna be able to fit this in here. The high side is going to be adding 1,000th, right? So what's my high value? 1 inch, that's the easy one. 1.00. Thank you. This could take a long time tonight. Oh, thank you, Garrett. What's my low side? Virtuals. You guys put them in. My Zoom people. What's my low value down here on my hole? Garrett says 0.999. Yes, and so does Aaron. Good. 0.999. Anybody else? Yep, we've got Tasia says 0.999. Yes, that is correct. 0.999. I had a 1 in front of there before, and I didn't want that. Okay. So these are the limits then of my hole. Now, MMC size. Is this an internal or an external feature? This is an internal feature, Deborah said. I need to take material away in order to create it, right? Absolutely. So if I go back over here, this is my internal feature. It's a hole, just like our current one. And the MMC size is the smallest or largest? Smallest size, exactly. Yes. So down here, I'm just going to put MMC in front of this, right? And that means that my largest size is my LMC. So internal features are opposites, I like to say, okay? For the MMC and the LMC. So now let's look at these numbers. We're going to compare the size of this shaft compared to the size of the hole. And we're going to determine, is this a clearance or an interference fit? What is the allowance? Okay. If we end up with a positive value, clearance. If we end up with a negative value, it's going to be interference. Now, they do the numbers down here for us. Okay. But the standard equation is the MMC size of the hole or the internal feature minus the MMC size of the shaft or the external feature. So since we're dealing with holes and shafts, that's the same verbiage. So our MMC size of our hole is 0.999. That is that number right there. Okay. And then the MMC size of our shaft is going to be that number right there. So notice that we end up with 0.999 minus 0.998, a positive 1,000th of an inch. Because it's positive, that means that it's going to be in a clearance state. We can freely put those together without any problem, okay, any resistance. Let's go over to the right. Let's find, I want you to write out the limits for our shaft on the right-hand side. Did you get the same as me? 1.004 on the high side, 1.002 on the low side. Okay. Now 2000s, I'm going to reiterate this again. As a designer, err on the side of you want to make sure that who's ever making this is going to be accurate with these numbers. And you don't want them to inadvertently maybe say, oh, plus or minus 10 thousandths if they don't know what the thousandths place is. And it can happen. Okay. The world that we live in industry, usually, especially if you're in the machining industry, we live in thousandth of an inch. So every like a, oh, a thou, or 10 thousandths or whatever. Well, 10 thousandths is actually what? 0.010. Okay. If you don't live in that world, then, you might not pick up on those zeros. So that's why limits are really a good idea. Now you're definitively giving that high and that low. Okay. I'm not saying these are wrong or not. They're valid types of tolerances, but especially when something needs to be accurate, 2000s is pretty accurate, then you might want to consider putting the limits in. All right. So now, which is my MMC size? Largest or the smallest for this shaft? Joe said largest. Chris says largest. Deb says largest. Roman is nodding largest. What about online? What do you think? Largest or smallest?
Largest.
Largest. Okay, cool. I think that was Aaron. Garrett says largest as well. You are correct. MMC size here. This is an external feature, largest size. So then my LMC is going to be this one. Now, same equation down here. Our base equation is the MMC size of the hole minus the MMC size of the shaft. So same MMC, same hole, 0.999, right? And then this time our shaft is, my MMC size is 1.004. So when I subtract those, I end up with a negative value. Negative means that they want to occupy 5/1000ths of this space together. Probably have to press that pretty hard. Okay. And again, neither one of these fits is right or wrong. They're just two different fits. Okay. They're just two different fits. Positive clearance, negative interference. Okay. Questions about MMC, LMC, interference, clearance, allowance, all that stuff. Cool. All right. Then what you get to do, like I said, this is really not a quiz. You can cross that out. This is our assignment, but it's called in this resource that I got this from, which I thought was really good. It labeled it that. So what you're going to do is you have 10 questions here, and they are referring to the illustrations above. So you've got shaft or pin C, hole D, shaft or pin E, and you've got hole F. Okay. And what you're going to do is, as you look down, you are going to answer the question. So it's asking, what are the MMC sizes of hole D, shaft C? What is the allowance between C and D? Now, if you need to look back and you need to determine, okay, to calculate allowance, I need to take the MMC size of my hole minus the MMC size of my shaft. To do that, that's totally fine. That's why we have those pages right there. So everything that you need to answer here, you should be able to find in the previous pages that we just went over. Does that make sense? Okay. So that is going to be something that you fill in, and then you'll be, again, handing this in. Now, there's two other parts to this assignment. We have part number 1, MS2437. And what this is it's just kind of going over some questions about the adjacent drawing here. So what I want you to do is I want you to fill in, okay, on that drawing on the next page, right here, tell me what the part number is. Tell me what the drawing size is. Tell me, is this an English or a metric drawing? And you should be able to, by looking at the dimensions, by looking at the title block and any notes, you should be able to answer the questions that we see here. Okay? All right. So it's kind of a print reading thing, if you would, kind of going backwards from what we've been normally doing. We've been creating the prints, but now I want to make sure that you understand and you can pull up a print and you can actually read it, which I'm confident you can. And then here's a second one where you're going to do very similar things. Questions are a little bit different. And then the drawing is on the last page here. Okay. So for this assignment, then the things that you're going to be handing in are going to be this MMC allowance quiz, okay? And then you're also going to be handing in the answers to the first supplemental drawing and the second supplemental drawing. Now, I realize if you aren't in class here, I made copies for everybody, okay? For those who are virtual, I know sometimes you may not have a working printer or the ability to print out, okay? That's okay. But then what you need to do is clearly state, this is the MMC allowance, you can call it the quiz then, allowance quiz. And then you're going to number 1 through 10, and you're going to write out your answers to these. Okay. And then what you're going to do is you're then going to write out the answers to the first supplemental part that has to do with part number 1. So you need to tell me what the part is, clearly let me know and then identify these items. You could type this out if you wanted to. I don't need to see your work, but you can type it out on a Word document or such. And then you're gonna do the same thing for this one. So you wouldn't have to scan, and those actually in the room could very well do the same thing too, if you wanted to just write the answers out like in a Word document. Okay, if scanning isn't an option. You can also, write the answers out, and I find taking a picture with your phone, I guess I say scan, but taking a picture with your phone and uploading it, that's another easy way to do it, as long as you have the Canvas app on your phone, and hopefully many of you do. Okay. So this is assignment 6B. Are there any questions on how to proceed here? Okay. All right. So then if there aren't any questions, then that's all that I have for this, and I'm going to stop the recording.